Hello, everyone. I'm Subhankar. I'm part of Altran Research and Innovation team, and I'm also the Service Assurance Module Lead in OSM. And today I will present the vision that we have for the Service Assurance module and how we want to achieve the closed loop operation in Service Assurance. The vision that we have is to create an autonomous network with open source MANO, and that means that we want to create a brain for the network so that it can self-learn, self-protect, and self-optimize, and take care of itself. Why it is required? Because as we are moving towards more complex networks, like we already are in the 5G era, where we are seeing array of new use cases, right from autonomous cars to immersive games to industry X use cases. So there are enormous amount of data, enormous amount of the devices that are coming in, and for humans to manage all these is not very easy, and the network has to be autonomous. Network has to adapt to the situation by assessing it continuously and taking the right action so that like it is always on. So for that, so what is the journey towards the autonomous network? The autonomous if you want to achieve an autonomous network, we have to move from the current reactive automation to a proactive automation. What does this mean? Today, most of the networks are people-driven. There's an army of people in the network operation centers of the service providers who are managing the network. The faults are coming in, they're analyzing it manually, they're finding out what is the root cause, and then trying to find how to solve it, and a field engineer is then assigned who can go and fix it on the field. Now, then we are slowly moving towards a degree of automation which is rule-based. So, for example, we are already seeing a lot of rule-based systems, like there are policies and thresholds, and when the threshold is breached, then some rules are triggered. But what we need to do is to be more proactive. That means we have to be predictive. That means not only what is happening now, what will happen in the future, that we have to find out, and then take an action. And the action should also be dynamic, and that is the prescription part. Like the same kind of anomaly, say I'm predicting an anomaly that there will be traffic congestion. But my actions can be different at different situations. For example, the traffic congestion can be because a lot of people have come into a place, so maybe I have to increase the bandwidth. But there can be a situation where the congestion is because there is a denial of service attack has happened. So I have to apply a firewall rule. So similar kind of prediction, but a different action has to be taken depending on what the current situation is. So you predict, prescribe, and finally reach an autonomous network through a closed loop automation. But I see this autonomous network is still some years away from us, maybe 2025 or beyond, because most of these service providers are still not very comfortable with applying actions directly, because that can break the network. So a more near term I see is an open loop automation where the recommendations go to the human network administrator, and the network administrator then decides whether he wants to take this action, he approves this action or not. So we call it an open loop. So these are the two, I will say, the end goal that we want to achieve. In a more near term, we want to achieve a human machine interface, whereas in a more long term, we want to achieve the fully autonomous network. So the heart of this system is the closed loop automation, and that is what we want to achieve in OSM. And there are three pillars to this closed loop automation. As you can see in the slide, you have to observe what is happening in the network, decide based on what you have observed, what action has to be taken, then you go ahead and act. So if I zoom into each of these pillars, observe means you need to have a granular telemetry to understand the different aspects of the network. That means there are different layers of the network, several different devices. So you should be able to collect data from different layers, different devices through their different interfaces. So you need a very advanced telemetry, and I will come to that in a moment. So you have to strengthen your telemetry interface to observe at a granular level that is required to fulfill that closed loop use case. Then you go to decide. In the decide phase, all the matrices that you have collected, you should be able to correlate those matrices, and then decide upon what is the current situation of the network. And then based on that situation, you are able to find out what is the appropriate action that I have to take. You're still not taking the action here, but you are deciding what is the appropriate action that has to be taken. And finally, you go and act on the orchestrated object so that the anomaly that is predicted, or the problem that is foreseen can be mitigated with this proactive action. And you don't stop there. You take a feedback from that action. You decide like whether the action that has happened, that you have taken, has actually prevented that problem from happening, or I have to take a better action. And you reiterate and you improve over time. And that is what the self-learning is. Now, there are several use cases of having a closed loop automation in the entire life cycle of a network. You can have a autonomous network planning. That means you can have a more data-driven way of planning your radio network, your fiber network, where you need more resources, which subscriber is using what kind of services. You can have a demographic information. So all this can help you to have a more autonomous and intelligent network planning. You can have a autonomous service rollout, which gives you a zero-touch service installation, provisioning, and so on. Autonomous network operation, like if a complex problem is happening, you correlate all the matrices to find out what is the root cause, and also guide the field engineer how to solve that problem. So that helps the field engineer, even if he is not fully skilled on solving a problem. With this guidance, he can go ahead and solve the problem, because he's already pointed like this is the place where the problem is, and this is how we have to solve it. Autonomous network security, I think this is one of the biggest area, because so there are thousands of attacks, I think, every hour. Even I think the GitHub went down a year back because of DDoS attack. So even your most trusted network partners can be compromised, and they become a botnet and attack you. You never know. So can this be discovered, and can this be stopped? You can do through, if you have an autonomous network. And of course, the predictive maintenance. You move from the current situation to a more forecasted situation. That means what can happen in the future. Say, if my network traffic is increasing, when it will completely be impossible for serving my subscriber on this current bandwidth. I have to increase the bandwidth, maybe. That is what a predictive maintenance. So there are array of use cases that you can do through a closed loop automation. You can make right from planning to the maintenance of the system completely autonomous. But as I said, there's a journey that you have to go through, and that is what we are envisioning, how OSM can help in this journey. So What we're trying to build is this closed loop automation, and this is the next level deep dive. So what you have seen earlier is the observe, decide, and act. So the observe is mapped to the sense part, where we are able to sense real-time network data from multiple telemetry interfaces, and going to the next level telemetry, like the streaming telemetry. We can use protocols like gRPC and so on. And then the decide part is divided into two different sub-blocks, I will say. The predict sub-block, that means where I find out what is the current problem, what can be the forecasted problem, and find out the anomalies. But I don't recommend an action here. I have a prescribe block where I prescribe what can be the action. And then I go ahead and act by calling my orchestrators to do its job. So this is, I will say, the main closed loop that we want to build. But there are subsidiaries to that as well. For example, the predict needs the machine learning models. So there will be a subsidiary block like to get the data, train your models, and use these models and send them back to the OSM predict block to predict the anomalies. You have a prescribe block where you need to find what action has to be taken. The recommendation engine has to be built here. So for that, we want to build a scoring based recommendation. That means if I have taken an action now and that action has not performed properly, maybe I will like to go ahead and take a different action next time. But how can I do so? If I can give a lesser score to the action that has not performed well now and take the next best action, maybe I can have an array of different actions and score them, and the action that have the higher scores is most likely to be picked up. So that way, I just don't, for example, scale every time I see there is a congestion, or I don't just send an alarm when there is a congestion, but I will take an action. Maybe sometime I even have to migrate a virtual machine, or maybe I will like to apply a different configuration that can mitigate the problem. So the same, as I said earlier also, the same anomaly can call for different action at different point of time, and that can be done through an advanced recommendation system. And then you have the act part. So just to give you, what we already have in OSM today, OSM service assurance today. So we have a great platform to start with. We already have a lot of elements that are available to like take them further and make them ready for the closed loop automation journey. For example, the MON part today covers the basic monitoring of the VNFs. We have an exporter mechanism. For example, we are creating an SNMP exporter to extract the SNMP, the matrices through the SNMP interfaces. We can have more such exporters. We have a threshold bit alerting system. We have a poll which helps in auto-scaling or generating alarms. Auto-scaling is like if the VNF has to be scaled, multiple videos have to be created, or and alarms has to be generated and webhook has to be invoked. Similarly, we have a dashboard through Grafana, which is which creates automated dashboards whenever a new VNF comes in. We have an optional log analytics model through Elastic. A newly created page placement model is there. It has also been discussed in the hackathon, Hackfest, if you have attended that session. So it optimizes the placement of the network services. So these forms the basis of creating the closed loop vision that we have. So if I map these modules to the previously presented closed loop automation architecture, so the sense part here will have those telemetry exporters like the XNMP exporter that is coming in release 8, and multiple other exporters that are in the roadmap. Then we have the MON module, which will do all the prediction part. So the machine learning model training will happen outside OSM, but the models will be provided to MON to do the prediction, anomaly detection, and so on. The POL will take up the recommendation engine part and decide on the action that has to be taken. It will not be static anymore, it will be more dynamic. And then the actions will be taken through the LCM or maybe through webhooks. So what we want to emphasize here is that we need not replace the current service assurance. We already have a great platform. We are building on that platform to move forward in this journey of the closed loop automation. And add more elements to that, more features to that in upcoming releases to finally have this vision of autonomous network. So the first step towards CL is already there. We have an autoscaling element and the alarms element in the service assurance. We have already demonstrated this in the Hackfest in last few days. So autoscaling means that whenever there is an alert that is generated, the VNF can autoscale and more videos can be added automatically when a threshold is crossed, and higher threshold is or a low threshold is reached. There is an alarm feature. That means if I want to inform an external entity, maybe through a webhook, that I can do through alarms, so that like an external alarm manager can take care of the different alarms. So this, I will say, is the building blocks or the first step towards the CLA that we already have. But we want to build on top of that. We want to add machine learning on top of it. For example, say I have a threshold today, right? So whenever a threshold is breached, an alarm is generated. For example, I have this kind of threshold, and if the threshold is breached, that alarm is or alert is generated. Then either I go for an auto scaling. So if the threshold is breached here, I go for an alert is generated, and so on. But the problem with this is that where I should put the threshold. So I should have a lot of knowledge to provide the right threshold value. So can I do away with this threshold? And is it possible that I do a machine learning based anomaly detection? That means what I want to do is I want machine learning to know what is the right behavior. So this light yellow, light blue colored area tells you like this is my area. This is my boundary of the normal behavior, and anything that goes beyond that should be a abnormal situation. So rather than a human setting the threshold, let the machine learning learn what is the normal behavior based on seasonality, trend, and so on, and then find out where the anomaly is. So this is just a simple example of what machine learning is able to do, so that the human will not have to provide those details, and through a continuous learning process, we can have a more accurate way of providing threshold. Now, so with this, so what is we need to do to achieve this closed loop automation journey? So if I take each of these blocks in service assurance today and see what we need to do, we need to have a more granular telemetry. Maybe it is time that we also include a streaming telemetry like gRPC, so that I can subscribe for the different events and matrices that I need, rather than getting everything, and what frequency I need. That is all configurable, and through notifications from the devices, I get the the telemetry information. So it is, rather than being a pull-based telemetry, it is more of a push-based telemetry. The second part is a ML-based anomaly detection. That means that rather than having a threshold, I allow the machine learning to learn what is the correct behavior, and based on that, the anomalies are detected, and those detected anomalies then calls for an action. And then we can move from more predictive to more, I will say, reactive to a predictive. That means not only now, what will happen in the future. So can I forecast my time series data and then apply a threshold to understand what can happen in the future? So in upward trend in traffic, say from now till few hours, say if it crosses a threshold, then maybe I should take action now rather than waiting for the traffic to completely congest my network. In the poll, what we envision is correlation of multiple alarms. That means alarms can come from the VNFs, alarms can come from the OSM itself, alarm can come from the VIMs. So can I correlate all the alarms to generate and consolidate and generate one alarm? For example, say if there is a problem in infrastructure, we'll have alarms from the infrastructure, from the VIM, we'll have alarms from the VNFs, we will have alarms from the services. So can all these be consolidated and a single alarm can be generated? And the second thing, as I mentioned earlier, is the recommendation engine. That means can a more dynamic recommendation of action can be done. The dashboard, once we have this granular way of detecting alarms, anomalies, and prediction thresholds, it should also be visible in the dashboard. That means all this alarm, the anomaly point should be clearly visible, so that whoever is seeing knows exactly why the threshold has breached and why these actions are being taken. The prediction value should also be there, and a more intelligent placement module. So in summary, we want to move towards a world of machine learning where I can have the more granular matrices, to have the right data for machine learning, use the machine learning to decide if there is an anomaly, machine learning to decide or to predict if it can happen in the future, and then generate the alerts. And these alerts can then be correlated together to find out the root cause and then generate a single alarm. And all this should be visualized in the dashboard so that whoever is seeing exactly knows why this alert is generated. And then the placement module should intelligently take the action by placing the modules in the right place. So with this, I want to end this my session with this thought from Albert Einstein, that definition of genius is taking the complex and making it simple. So our vision should be to simplify the network so that we can talk about innovation, we can think about new ideas rather than struggling with the complexities of the network. So with that, I end my presentation, and if there's a question, please let me know.
So thank you very much, Subhankar. That was a very thorough presentation. We definitely have time for a few questions. We're still running a little bit ahead of schedule. So if anyone would like to ask a question, please do so now, and feel free to use the chat window as well.
Hi, this is Peter Willis from BT. Yeah, that's a very good presentation, and as I mentioned, we've been looking at the same subject matter for some time. One of the interesting things about that we found out about training your machine learning models on is that sometimes you have to invalidate the whole what you've learned before. So, for example, we were looking at optimizing distribution. I think it was Elasticsearch, and then they changed the version of Elasticsearch. It was an update, and its behavior changed. So everything we'd learned before became invalid. So that's something to watch out for in your predict loop, is that when something changes in the network, it can invalidate previous learning. makes that complicated. And the other thing that's highly non-linear as well is when you in your prescribe loop is when you calculate the reward. A slight change in how you calculate the reward makes a big difference in the outcome. So that's always a dangerous situation to be in. So if you tweaked how you calculate the reward very slightly, you could rearrange the entire network, which is somewhat disruptive. So that's something else to have a think about as well.
Absolutely, I think they're very good thoughts. So on your first question on the predict, yes, machine learning is very difficult to tame. And if you don't have the right model, which is reflecting the right situation on ground, then maybe you can be completely off the mark. So we have to understand the learning that I have done and the data that I have, what is the delta between that. So there are a couple of mechanisms the data science world is exploring, that what is the data drift that I have, so that I have to retrigger the training. Now, does this training means that I have to unlearn and relearn everything? That means I have to do a machine learning training right from scratch and discard the previous training, or maybe I can do a more delta learning. That means I have to just learn the new thing that has happened and I can still keep it. So I think these are the few things the data science world is thinking about. So yes, I mean, it's not easy. It is easier said than done, but these are the few things that we have to consider, and we have to look for this data drift to understand what kind of training that I need. So that is the first part. The second part is about is mentioned about the recommendation piece, where a slight deviation in or there's a slight error in the scoring of the action can completely make it off the track, and maybe you start taking wrong actions every time and disrupt the entire network. So that maybe to stop that kind of situation, maybe we can have a human in the loop. So though you recommend it, but you don't allow the action to be taken automatically, a human can vet that action. I will call it as a guided action, so that the action that I am taken is vetted by a human expert, and then the action is taken. So once you do it for some time, then maybe the system learns, and then it can be more mature to take action itself. So to start with, maybe we need to have the human in the loop, and going forward, maybe the network can become more autonomous. So the slide I showed about the journey of the intelligence and automation. So there were two bubbles. There's a blue bubble and the green bubble. So the blue bubble is the open loop. So I think that is what I see as a near term. That means a human in the loop, and he's vetting those actions. And then when things become more mature, we can have an autonomous. But yes, I mean, I completely agree. It's not easy, and we have to be more watchful about the things.
Yeah, it's very good research. So excellent, thanks.
Thank you.
So I think at this point, we do not have any other questions. So Subhankar, thank you again